Hello everyone. The title of my paper is Design of Digital Image Information Security Encryption Method based on Deep Learning. Due to the high degree of overlapping of digital image information, the security encryption ability of digital image information is weak, and encryption accuracy is low. A security encryption method for digital image information based on deep learning is designed in this paper. Determine the connection form of the deep learning network, and based on this, select the key learning function, decipher the digital image information, and complete the digital image analysis based on deep learning. According to the scribbling result of the image information, a circular index table structure is established, and then the secure encryption of digital image information is realized by solving the value range of the security parameter. So, as you know, digital image encryption is a branch of cryptography, and it is also the combination of digital image processing technology and cryptography. However, since each participating individual and it can obtain information on the internet, the encryption of information is particularly important, and preventing illegal individuals from obtaining encrypted information is exactly the subject faced by cryptography. A security encryption method for digital image information based on deeper learning is designed in my paper. According to the deep learning network connection form, the learning function is selected. The image information is deciphered, and the digital image is analyzed. The digital image information security encryption is realized through scrambling, processing, cyclic index table construction, and security parameter calculation. This method has stronger encryption ability and higher encryption accuracy. According to the deep learning network connection form, the learning function is selected to decipher the image information, and the input analysis of the digital image information can be realized. This chapter will conduct research on the above content. So, the deep learning network architecture contains a large number of data tables parameters, most of which are located in the fully connected layer, and the risk of overfitting is serious. Therefore, two main measures are also adopted in the training process to reduce the risk of overfitting. The first is the increase of data. The most direct measure to prevent overfitting is to expand the training data set, allowing the network to learn more features of different images under the same category. So, we designed the deep learning network basic connection architecture, and it's shown in Figure 1. The learning function is built on the deep learning network architecture and uses the security parameters configured by the handshake protocol to support functions such as compression, encryption, and encapsulation of the upper layer data. Image information correcting identifies applications based on the port numbers in the headers of deep learning network packets, that is, classifying traffic by mapping the port numbers to specific applications. The principle of this classification method is very simple. It only needs to read the first data packet in the network data stream to be successfully identified. The identification efficiency is very high, and specific implementation is extremely simple. With the support of the deep learning network architecture, according to the execution process of scribbling processing, cyclic index table construction, and the security parameter calculation, the secure encryption of digital image information is completed, and the smooth application of the deep learning based on digital image information security encryption method is realized. Generally speaking, the reproduction process of digital image information encryption behavior by deep learning network can be understood as computer simulation reproduction or optical reproduction. The computer simulation reproduction process can be realized using only one computer. In the optical reproduction method, a corresponding experimental framework needs to be built. In the framework of the optical reproduction experiment, when the beam emitted by the laser is collimated and expanded, the spatial light modulator loads the hologram. Finally, it is received by the basic learning mode and transmitted to the computer for display. The corresponding option steps are as follows. First, use plain text and standard sequence conditions generated by the deep learning network framework. Then, use the chaotic sequence to control the cyclic shift of the reference sequence to generate a metric table. Finally, transpose the metric to get a circular index table. The circular index table is dynamically generated and has a strong connection with the plain text, which can effectively resist selective plain text attacks. The number of occurrence of each pale value in a digital image accounting for the total text value of the plain text can be regarded as a probability value. So, an advantage of using deep learning coding to encrypt plain text image is that the result of deep learning coding and encryption changes according to the change of plain text, which can solve the problem that some algorithms are not strongly related to plain text. So, input the select digital image into Windows host, close the control switch, and judge the processing capability of the secreted encryption method for digital image information according to the indication level of the relevant equipment components. In order to ensure the authenticity of the experiment results, when changing the encryption algorithm, the model of the selected experimental component remains unchanged. So, there are steps of experiment preparation. You can see step 1, step 2, step 3, step 4, and step 5, step 6. As you know, step 4 is the most important step in this because it needs to clear the existing experimental results again and debug the Windows host to the initial state. So then we can use the digital information security encryption method based on the kernel function to control the Windows host and record the specific numerical value changes of the information nicing index, the degree of information stripping, and the image physics level. The last is step 6. You can see that compare the obtained experimental results and summarize the specific experimental rules. Then we get some conclusions. This paper designs a security encryption method for digital image information based on deep learning. Determine the connection form of the deep learning network. Select the key learning function and decipher the digital image information. The image information is correct. The structure of the circular index table is established, and security encryption of digital image information is realized by solving the value range of the security parameters. So, the experimental results show that the method in this paper solves the problem of weak security encryption ability and low encryption accuracy of digital image information. Due to the high degree of overlap of digital information, however, in this study, building a network system as an experimental environment is limited in practical application. So in future work, we will work on it. That's all. Thanks.